Hello, geometry students. Today we're going to be going over the Unit 6 workbook. This one's having to do with three-dimensional figures. So like this rectangular prism here, okay? And we're going to be talking about how to find the surface area and the volume of things like that. And it's going to be a long one. So buckle up. Let's get started. And I'm going to go ahead and share my screen here. And let's go ahead and let's open this up here. And so go ahead and open your Unit 6 workbook. And let's go down. And we're going to open up to page number 6. And first of all, let's talk about some of the things we were going to see on three-dimensional shapes. So we have the faces. So each face is a flat surface on a three-dimensional shape. So for example, this rectangular prism that I'm holding, this tissue box, has 6 faces. That has a front and a back, a left and a right, and a top and a bottom. Each of those is a face. So an example of a face for this shape is this rectangle ABCD. So this back one right here. So what would be another face here? So we could say ABFE is a face. You could write that. Or triangle ADE is a face, right? Triangle ADE is a face. There's other things you could write up here. A vertex is any point, so any corner point. So E is an example of a vertex. Well, so would F. F would also be another vertex. You could say C is a vertex, right? Any of the corners, any of those points is a vertex. And then an edge. An edge connects 2 of the vertices together. So the example they give is EF, and they put a little bar on top. So generally line segments, which edges are line segments, they get a little bar on top. So another example might be AB is another edge to this. So when you have a three-dimensional figure, this is an edge, this is an edge, this is an edge, right? Okay. Now, Euler's formula basically allows us to write this relationship between the number of faces, vertices, and edges. So if you take a three-dimensional figure and you look at the number of faces plus the number of vertices, that'll equal the number of edges plus 2. So how does that work? Well, you could basically just use this formula here to find a missing one. So if they give you the faces and edges, we could find the vertices. Or if they give you the faces and vertices, you could find the edges, right? So let's look at this example and see if we can use this Euler's formula to find the number of vertices. So the number of faces is 20, so F is 20, plus the number of vertices, we don't know yet, equals the number of edges, 30, plus 2. That 2 doesn't change. So that would be 20 plus V equals 32. To help us solve for V, to get V by itself, we're going to subtract 20 both sides of the equation. So that gives us that the number of vertices is 32 minus 20, which is 12. So a shape that has 20 faces and 30 edges would have 12 vertices. Now I want you to pause the video. Well, pause the video and go and do the problems here on page 11. So see if you could do number 4, 5, and 6 on page 11. I showed you the example already. Now, if you take a three-dimensional shape and you kind of cut along its edges and you flatten it out, you can create something called a net, which is basically a flat two-dimensional shape that is formed from a three-dimensional figure once you flatten it out. And you can kind of see that there. If you take this triangular prism here and you cut along the top and the edges here and unfold it, you can get this shape here, right? See, the base is that gray, and then You have the two rectangles on the side, two triangles up bottom. Now, when you flatten out to a net, it changes Euler's formula a little bit. Instead of a +2, it would say +1. Okay, so Euler's formula changes when you flatten it out to a net. Before, remember, we'd have a +2 here. But when you flatten it out to a net, it's a +1 instead. Let's practice by creating a net for this one here. So if this is the base here, painted blue, I'm going to go ahead and draw that first. So here's the base. And we can think of this box. It should have 6 total faces, right? This box will have 6 total faces. So I need to make sure my net has the same number of faces. So here's all the edges of it, right? The sides. Now the top, I can connect it to the top should be the same exact shape as the bottom, but I'm going to connect it up here. Okay. Now, if you connected the top over here, that's fine as well. Now let's verify Euler's formula. So first, the number of faces. Well, that's 6 faces. 1, 2, 3, 4, 5, 6. 6 faces. Plus the number of vertices. So for the vertices, I'm going to go and draw them orange. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 vertices. Equals, and now let's do the edges. So the edges, let's go ahead and mark those purple here. 1, 2, 3, 4, 5, 6, 7. Make sure not to double count. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 edges, and then there's a +1 over here. And we know this is good because 6 + 14 is 20, and 19 + 1 is also 20, so that checks out. So that's how we know we did our net correctly, is if the Euler formula does indeed play out correctly. Okay. Next, let's talk about, let's actually, after we've done this example here, let's take a look at page 9 here. So let's look at this quick check here. So a cross section is what they're talking about here. So that's basically if you take a three-dimensional shape and you cut it. So here they've got a triangular prism and they've cut it with this plane here, right? They cut it with this plane. So you could see what the cut would look like would be this rectangle here. Okay, so you can imagine this paper cutting this shape. And what it's asking about is what would the shape, if you were to like cut that shape, right? Cut it. And then you looked at the cut, what shape would the cut look like? So in this case, if you cut it like this, the cut would look like a rectangle, right? Now there's other ways you could have cut it where it might have looked different, like a triangle if you would cut it like differently. But if you cut it like this, the cross section would be a rectangle. Here with this cut, if I cut it like that, and imagine you just picked up the top and you looked at it, what shape would that cut look like? Well, that would be a rectangle also. So this one will also be a rectangle. They won't always be rectangles, but these first two examples are. Now let's go on to page 10 here. Here it says list the edges of the polyhedron below. So here we have looks like a triangular prism, and they want you to list all the edges. I'll list a couple of them for you. So AB is an edge. So AB is one of the edges. What would be another edge here? Well, how about BE is also edge? So anything connecting two vertices, and I put a little bar on top because these are line segments. So FD is also another edge. Okay, so just make sure you list all the edges. There should be 1, 2, 3, 4, 5, 6, 7. There should be 9 in total. So make sure you list all 9 edges. Now here, list all the vertices. There should be 6 in total. So A is one of them. B is one of them. Again, the vertices are just the points, the corners of the shape, okay? So make sure to list all those. Here, it asks for faces and edges. So edges is just like how you did here. So make sure you list all the edges and the number and the faces. For each face that you mention, you need to list all the vertices for that face. So this face up here, this one right here, this top one, I guess, we would say A, B, C, D. A, B, C, D is a face. So for our faces, A, B, C, D is one of them. What would be another face on this polyhedron? How about A, D, H, E? A, D, H, E. Okay. Why don't you go ahead and finish the rest, listing out the rest of these faces. There should be 6 total faces, 6 total different faces, and also list all the edges. Okay. So there should be 12 edges. So list out the rest of the faces that we didn't do and list out all the edges, just like how we did for number 1. So pause the video and go ahead and finish that. Here, these ones you should have already done. On page 12, we're going to draw a net for the figure and verify Euler's formula for the 2-dimensional figure. So remember, Euler's formula, when you're drawn out into a net, is this: F plus V equals E plus 1. Okay, so when it's flattened out to a net, make sure you're using the plus 1 version. So let's flatten this out to a net. So you can imagine I'm going to keep the base. I'm going to keep the base in the middle. And you can imagine this pyramid kind of unfolding here. You'd have a triangle connected to each edge of the base. My picture is not the best. Hopefully you do better. But then we want to verify Euler's formula. So how many faces are there? 1, 2, 3, 4, 5 faces. So our F, the number of faces, is 5. Plus the number of vertices. I'm going to go ahead and maybe I'll highlight here. So number of vertices, 1. It's not working. Okay. Let's just do green here. Number of vertices, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I count 8 vertices. So that's 8. Equals, and the number of edges. So again, let's go through it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that should be 12. And then we still have a plus 1. That plus 1 just comes along. So we can verify Euler's formula because 5 plus 8 is 13. And 12 plus 1 is also 13. So that's correct. There. Let's draw a net for this one. So I'm going to leave the base in the middle. I like doing that. So that's the base in the middle. And you can see the rectangles. There's 2 rectangles kind of coming up on this. So I'm going to put those here. And then when you unfold it, you have 2 triangles kind of coming out like this. Okay, now see if you can verify Euler's formula. Again, counting the number of faces, the number of vertices, and the number of edges, plus 1. So then same thing as what you did here, where we count the number of faces, number of vertices, number of edges, and make sure you get equals here, okay? If these are not equal, you might have counted the number of edges or vertices or faces wrong. Lastly, I'll help you with this net here. Again, here's the base here. In this case, the base has 5 sides to it. It's a pentagon. So here we have a pentagon shaped bottom. Let's see if I can draw that reasonably well. Okay, I'll take it. And then Each of these will have a triangle attached to it. Okay, so then again, same as what we did up here. Count the number of faces, count the number of vertices, count the number of edges, and then put them in that formula to verify that it works. Okay. Now let's go on to page 13. So here we want to look at what is the cross section that this cut makes. So in this case, if you use this flat plane to cut this cone and you cut it just like that, what shape would you see if you looked at the cut? Well, in this case, that would be a triangle. Okay, so in this case, the cross section makes a triangle. All right, hopefully you can see why that's the case. In this one, what would the cross section be from this plane cutting this cylinder? Well, if you cut it vertically, that would have been a circle, right? But it's cut like horizontally. How would that look? Well, if you looked at that cut, what would it look like? Well, that would be a rectangle. Okay, rectangle. Okay. For this activity, the concept bite on page 14, I already went over this in another video. So if you need help on that, you can go ahead and watch that video after watching this video, and it'll go over this specific. So now we're going to talk about surface area of prisms and cylinders. So surface area is basically, if you have the shape, if you have the three-dimensional shape, it's the area of all the surfaces on it. So you can imagine the area of this flat face, the area of the top face, the area of all the faces, and you take the area of each of those faces and add up all those areas, and that gives you the total surface area. Another way to think of it is, if you're going to wrap the object with wrapping paper, what is the minimum amount of wrapping paper needed? So imagine wrapping paper, wrapping it without any overlaps. What would be the minimum amount of wrapping paper that you would need? That's the same as the surface area. Now, in order to be able to calculate surface area, we need to be able to find a couple of things we want to talk about here. So first, for three-dimensional shapes, what is considered the base? Now, I know that you might think of the base as what the object is sitting on. And in a lot of cases, that's true. But instead of thinking it that way, though, I want you to think of it as if there's an identical shape opposite from itself. So in the example they give here, these two triangles, the top and the bottom, are the bases, because notice there's an identical triangle, a congruent triangle, so top and bottom, and they are parallel to each other, right? These planes would not cross each other. So parallel planes that are congruent, those we want to consider as the base. So when we look at this one, you might be tempted to say, oh, this rectangle, that's the base. Well, that would not be correct, because there's not a congruent rectangle on the other side. Instead, the base would be these two triangles. Okay, notice these two triangles are congruent to each other, and also they're on opposite sides. These planes, even if you extend those planes forever, they would not touch each other. So those are our two bases, so the two triangles. So triangle, an example of a base would be triangle ABC. All right. You could also put triangle DEF. That's acceptable as well. These are the two bases of this triangular prism. A lateral surface are the other surfaces. So a lateral surface is the surface connecting the two bases. So if these two triangles are my bases, a lateral surface connects those two triangles. So the surface ABED would be an example of a lateral surface because it connects my two bases. So ABED is an example of a lateral surface. Now, that's not the only one, right? ACFD is also another lateral surface, and CBEF is another one. A lateral edge is an edge that connects the two bases. So AD is an example of a lateral edge. Again, that's not the only one. BE is a lateral edge, and CF is also a lateral edge. Again, it's an edge connecting the two bases. So why did we go over all that stuff? Well, we want to be able to identify bases because that's going to be very important when we're calculating surface area and volume. Now, the rest of this unit is going to be about surface area and volume. So it's very important that we know how to find the base, how we think about what's a lateral surface. So when we calculate the surface area, let's go ahead and do this one together and talk about each step of the way. So first, when it says perimeter, what they mean is perimeter of the base. Okay, that's important. So it's the perimeter of the base. And you might want to write that down. So when you look at the base, in this case, this rectangle right here is the base, what would be its perimeter? Well, the perimeter is the edges of that shape. So when you have a two-dimensional shape, like the rectangle, the space, its perimeter is walking around that shape, basically. So if you were to walk all the way around this base, what would be the total distance that you walked? Well, that's the same as asking, what's the perimeter? Okay, so when you think about that, it's 17 across here, but it's also 17 on the back side. It's 8 over here on the right, but it's also 8 over here on the left. So if you were to walk around this shape, this would be 17. You'd have to walk 17 twice, right? And you'd have to walk that 8 twice. So our perimeter for the base is 17 plus 17 plus 8 plus 8. Okay, so that would equal 50. So the perimeter of the base is 50. Okay. Now, why is that important? Well, that's going to help us to find the lateral area. And the lateral area is the area of all the lateral surfaces. So it's the front, it's everything besides the bases, basically. It's the middle section. Everything besides the bases is going to be the lateral area. And the way we can calculate it is by finding that perimeter of the base, which was 50, and you multiply by the height of the object. So the height is the distance connecting the bases, okay? It won't always be up and down, the height. Like if the object is on its side, it might be left and right. So don't think of the height as always going up or down or whatever. But in this case, it is, right? So the height in this case is 12. And so our lateral area would be 600. So that tells me the area of all the lateral surfaces. So now I know the area of all the lateral surfaces. That's the area of not the bases, but all the other surfaces. Now let's figure out the area of the base. Okay, well, the base is a triangle. So the base is did I say triangle? The base is a rectangle. And the way we find the area of a rectangle is simply length times width. So when we are finding the area of this rectangle, it would be 17 times 8. So the area of the base area is 7. We did 17 times 8, the length times the width. And that gives us 136. Now that gives us the area of the bottom, right? But the top is the same, right? The area of the bottom and the area of the top are the same because those are congruent shapes. They're congruent, they're the same. So for both the bases, that's just the area of one of the bases. So for both bases, we would multiply by 2 because there's 2 of them. Or in other words, just 136 plus 136, the top and the bottom bases added together. which is 272. Okay, so now what we have is the total surface area, meaning all of the surfaces. We would need to take the lateral area. So that's the area of all the lateral surfaces, plus the base areas for both bases. So that's 272. So lateral area plus the bases area gives us the total surface area, which in this case is 872. Now, this is how you find the surface area of a rectangular prism, but it also accounts for other shapes that aren't just rectangular prisms, but they might have different area formulas for the base, depending on the shape of the base. If a base is a rectangle, you just use this. So this is for a rectangle base. But if it was a triangular base, so if your base was a triangle, its area would be 1/2 length times width. So you got to kind of know that one offhand too, all right? Because sometimes you're going to have a base that's a triangle. But we'll go over an example like that. So don't worry too much. And let's actually go over these examples for surface area. Let's go over them right now. So I want you to skip. We're going to skip this for right now. We'll come back to this for the cylinder. We'll come back to that. And let's just go on to page 18. And let's talk about the surface areas of these ones. So this one's very much just like what we did. So first we want the perimeter of the bases. Okay. So I'm just going to put P for perimeter, but you know that that's perimeter of the bases. So the perimeter of the base is going to be 13 plus 7 plus 13 plus 7. So it's going all around that base. It's going to be 13 and 7 here. So the perimeter of the base would be 40 if you add that together. So that's going to be 40. Now we want to find the lateral area. So I'm going to put LA for lateral area. But the way you find that is you take the perimeter of the base times the height of your three-dimensional object. So in our case, that's going to be 40 times, what's our height? Well, that's 9 in this case. So our lateral area would be 40 times 9, which is 360. So again, that's the lateral area. So that's the area of all the surfaces except the bases. So not the bases, but this is the area of the rest of the surfaces. So now we need the base area. So first, let's find the area of one of the bases. So this is a rectangular base. So we do 13 times 7, length times width. And that equals 91. So the area of the base is 91. Now both bases together, we would multiply by 2. So both the base areas together is 2 times the base, which is 2 times 91, which equals 182. So that would be the area of the two bases. So now you take the area of the two bases, the total base area, plus the total lateral area, and you add those together to get the surface area. So in our case, the surface area will be 360 plus 182, which is 542. That would be the area of all the surfaces of this combined. So this is our final answer. That's the surface area. Again, adding the lateral area plus the area of the two bases gives you the surface area. All right. Now, Let's take a look at this triangular prism. So here, what is our base in this case? So don't get confused. This rectangle that it's sitting on, this is not the base. That is not the base. The base are these two triangles. So the two triangles that connect, that are parallel to each other, and also congruent. So when we find the perimeter, we want the perimeter of the base. So if we want to find the perimeter of this triangle, imagine walking all the way around this triangle. What would be its perimeter? Well, you would add 6 plus 7 plus 8. 6 plus 7 plus 8. So that's 21. So the perimeter of the base in this case is 21. Now to find the lateral area, we take that perimeter and we multiply by the height. So what's the height in our case? Well, the height is what connects the two bases. So the distance connecting the two bases, that's 12. So in our case, the perimeter is 21 and the height is 12. So again, the height is what connects the distance between the two bases, which is 252. So this is our lateral area. This is one of our key things we need. And that's the area of all the surfaces except for the bases. So now let's find the base area. Now again, this shape for the base is a triangle. So the way we find the area of that triangle will be 1/2 length times width. So in our case, that's going to be the area of that base will be 1/2 6 times 7. 6 times 7. So that would be 21. Now if we do both the bases, so since there are two bases, we multiply by 2 to find the total base area. So that would be 21. 2 times 21, which is 42. So the two triangles will have a total area of 42. To find the surface area, lastly, you take the lateral area plus the two bases, which in our case will be 252 plus 42. And that'll give us a total surface area of 294. Okay, hopefully I'm not going too fast. Hopefully you're able to see what we're going for here. So now let's go back up to page 17, and we're going to talk about the surface area of this cylinder. Well, it's very similar. First, we find the lateral area, which we do by finding the perimeter of the base times the height. Now, the shape of the base in this case is a circle. So the way you find its perimeter, well, for a circle, it's usually called circumference, but they're calling it perimeter. And just for consistency's sake, I'll call it perimeter. But just know that for a circle, it's usually called the circumference, but it's the same idea. It's the distance around the shape. All right. So the total distance, if you were to walk around that circle, that's its circumference. But we'll just call it perimeter. I might use those words interchangeably for this case. Now, how do we find that for a circle? Well, it's it's 2 times pi times the radius. So in our case, that's going to be 2 times pi. And what's the radius of our circle? Well, it's 6. So in our case, the circumference will be 2 times pi times 6, which will be 12 pi. Okay, 12 pi. To find the lateral area, which is which is kind of like the middle, the barrel of the cylinder, what would be the area of that shape? Well, you take that perimeter, which is 12 pi, and you multiply by the height. Now the height in our case, again, connecting the two bases, is 11. So our lateral area will be 132 pi. Okay. Now, how do we find the area of the base? So again, the base is a circle in this case. So how do we find the area of a circle? So here's another one you need to know. The area of a circle is pi times r squared. So our base area, we're going to be using pi times r squared. So that's going to be pi times, what's the r in our case? So what's the radius? That's 6. So it's going to be 6 squared. Now remember, squared means that number is times itself. So 6 squared means 6 times 6. So that's going to be 36. So our base area for our first base is 36 pi. Now for the both bases, you simply multiply that by 2, same as what we did before, which makes sense because there's 2 of them, right? There's 2 bases. So 2 times 36 pi is 72 pi. Lastly, to find the total surface area, we add the lateral area plus the base area for both bases. So our lateral area, again, is 132 pi. And we're going to add both the bases, so that's 72 pi. Okay, don't leave off the pi here. So that's 204 pi. Okay. So I'm going to go over one more example with you right here. So, and you can see the example up here as well. So the first thing we want to do is find the perimeter, also known as the circumference, which is 2 times pi times the radius. So in our case, that's going to be 2 times pi times 8. Or in other words, 16 pi. Now to find the lateral area, you take that circumference we just found and you multiply by the height, which in our case is 12. $192 pi. So that's the area of the barrel, basically, of the cylinder. Now the base, again, you use the formula for the area of a circle, pi r squared. So in our case, that's going to be pi times r, our radius is 8, and that gets squared. So that's going to be 8 times 8, that's 64. So that's 64 pi. That's the area of one of the bases. So if we want to double that, because there's 2 of them, we're going to multiply that by 2. So that's going to be 2 times 64 pi. Which in our case is 128 pi. So we add the lateral area plus the area of the 2 bases, and that'll give you the total surface area, 320 pi. So we take the lateral area plus the 2 bases, and that gives you 320 pi. And this here total surface area. So surface area. Okay, so you've seen a couple examples. I want you to go and try this one on your own, number 4 on page 19. Give it a go. Do your best. Now we're going to talk about surface area of pyramids. So what makes a pyramid a pyramid? Well, a pyramid only has one base. So unlike what we saw with the other ones, the pyramid only has one base. And then it has triangles kind of connected to that base, and those triangles always meet up into a singular point at the top. So that's kind of what makes a pyramid a pyramid. You have the base, you got the vertex at top, and then you have the triangles that kind of come up to that point are called the lateral faces, okay, or lateral surfaces. Now there's other key things we need to know about this thing. It might be hard to see, but hopefully you can see it on your own on your own workbook on page 20. You have the slant height, which is usually denoted with a lowercase l. We have the apothem, which is denoted with a lowercase a for apothem. And then we have the altitude height. So that's from the vertex straight down. From the vertex straight down, that's the height of the pyramid, h for height. Now the weird one is the slant height, right? So that's going from here, from the middle of one of the lateral faces to the top, right? So like from here, going up the side of this triangle to the vertex. That's the slant height, okay? That's L. Now, again, to find the surface area, the total surface area, you would find the area of the lateral surfaces, so all the triangles, basically, the lateral surfaces, plus the area of the base. Now, you don't need to do times 2 for the base here because there's only one base, right? So for pyramids, there's only a single base. So the way you find the lateral area is you do 1/2 P times L. So what is P again? Well, P is the perimeter of the base. So when it says P, that's the perimeter of the base. L is the slant height. So when I'm looking at this shape here, what would be the slant height? What would be my L? Well, that's 10 here. That's 10. So that's our L. That's our slant height. You can see it going up the slant. The perimeter would be walking all the way around the base. Now, in this case, my base is a hexagon. It's got 6 sides to it. And each one of these sides has a length of 8. The 4 here is talking about this inside, the apothem, right? The apothem is 4. But you can see here, it's 8 along this here, and going around this entire hexagon, 6 sides. Each of these 6 sides will be length 8. So the total perimeter will be 8 plus 8 plus 8 plus 8 plus 8 plus 8. Or in other words, 8 times 6, because it has 6 sides. So that's why the perimeter for this one, they say 8 times 6, because each side along the base is an 8, and there's 6 sides along the base. And the L, the slant length, so when they say 1/2 P times L, that's 1/2 P is 8 times 6, L is 10. So that's where they got this 240 from. Now to find the area of the base, so again, this is the formula we're going to need for lateral area. So make sure you know this formula for the lateral area for a pyramid, 1/2 P times L. For the area of the base, it's 1/2 P times A. So again, the perimeter of the base times A. Well, what's A? A is the apothem. So that's where the 4 comes in. Okay. Lastly, to find the surface area, you add the lateral area plus the base area. So lateral area plus base area gives you total surface area. Okay. With that in mind, let's find the lateral area for this one here. So again, for our lateral area, our formula is 1/2 P, that's the perimeter of the base, times L. L is the slant length. So in our case, we need to find P and we need to find L. So in our case, P is going to be the perimeter of the base. Our base is a hexagon, once again, 6 sides. And each side of that is 4. So our perimeter is going to be 4 times 6 sides of that. So that's going to be a perimeter of 24. The slant length, that's the only other number here, but it's going from here to the vertex. That's 10. So our L is 10. So to find the lateral area, which they're only asking for the lateral area, most of the time they're going to ask for surface area. But here they're only asking for lateral area. It's going to be 1/2. So our lateral area will be 1/2 P, which is 24, times L, which is 10. So our lateral area will be 120. This is the area of all the triangles, not the base. Okay, hopefully that makes sense. Now, what about an example? Here they're asking for the lateral area, but there's a problem. In order to find the lateral area, we need L. But they don't give us L. You see, it just has a letter L. They don't tell us what number that is. What's that length? We don't know. But if you notice, you could see there's the height here, which is from the vertex straight down is 18. And we have this right triangle here. And they kind of drew it to the side with the height of 18. And then this length is 6. How did they get that 6? Well, they know the length all the way across here is 12. And this right here, this bottom part, is half of 12. So that length is 6. Okay. Does that sort of make sense? I hope it does. Because this is 12 across here, which means this is only 6 across here. Now, this forms, hopefully you could see, that forms a right triangle. A right triangle. Now, what do we know about right triangles? Well, we can find a missing side length of a right triangle using the Pythagorean theorem. A squared plus b squared equals c squared. And in this case, the c, or the variable that's in c spot in the hypotenuse, is L. So our a and b are 18 and 6, and the c, in our case, is L. So you'd plug it into the Pythagorean theorem. A squared plus b squared equals c squared. Here our a is 6, our b is 18, and the c, the hypotenuse, is unknown. We just put L. Solving for that, they skipped a step or two, but I can show you how they did that. So 6 squared is 36, plus 18 squared (324) equals L squared. 36 plus 324 is 360. And then to get rid of the squared, you square root both sides. So that gives you L by itself. And then when you do square root of 360, you get about 19. So that's where they got this L is approximately 19. Then, now that you have L, now you can find the lateral area because we know L is 19. The perimeter, well, the shape of the base is a square, right? So it's 12 on each side. So 12 times 4, only 4 sides on this pyramid. So 12 times 4, that's where they got that. So 12 times 4 is 48 times 19 times 1/2, multiplies all together, you get 456. That's the lateral area of this pyramid. Okay, so kind of the key takeaway here is that sometimes they don't give you L, and you'll have to use the Pythagorean theorem to find L in those cases. Okay, so make sure you have this Pythagorean theorem kind of in the back of your head because this will come up again. let's practice it here to help us find L for this pyramid here. So I'm looking at this right triangle right here. And I'm going to go ahead and draw it over here. Kind of bigger. The height of it is 9. Here's the right angle. L is the slant length, so that's going across here. And then this length is half of that, so that's going to be 4 here. 4 here. Using that, we can find L using the Pythagorean theorem. Here, our A and our B are 4 and 9. So 4 squared plus 9 squared equals, and our hypotenuse, in this case, L squared. So that's going to be 16, because 4 times 4 is 16, plus 9 times 9, well, that's 81, equals L squared. 16 plus 81, 97, equals L squared. Now, how do we get rid of that squared? Well, you square root both sides. To get rid of squared, you square root. So that's going to leave you square and square root cancel, leaving you with L on the right side. And the square root of 97 is 9.85, roughly. And that's your slant length. Okay. Now, if they asked you to, now you'd be able to find the lateral area, because you'd find the perimeter times the slant length times 1/2 using this formula. But they didn't ask you for the lateral area. They just wanted the slant. Okay. Now we're going to talk about cones, surface area of cones. But before we do that, let's go ahead and go down and try these few pyramid exercises. Okay. So let's go ahead and do this one here. So what's the lateral area of this pyramid below? So to find the lateral area, again, it's the formula we need is 1/2 P times L. The perimeter, P, that's easy enough. That's the perimeter of the base. So notice the base is a square. It's got 4 sides. And each side of that square is length 15. So the perimeter of that square is 60. How'd I get that? 4 sides times each one is 15 gives me a perimeter of 60. Okay, right? 15 plus 15 plus 15 plus 15. Walking around the outside, that's 60. Now what about L? Well, they don't give you L. That's from the vertex diagonally down. That's what we want to know. Well, that's our L. Okay, so now we could think about the right triangle here that makes this. So if they don't give you L, you're going to have to do this right triangle business. Okay, you're going to use that Pythagorean theorem. So I'm going to go ahead and draw this triangle kind of outside here so you can see it a little more clearly. And with a height of 23, the L along here, the slant length. And then what would be this length here? Well, it would be half of what this is. So this is 15. What's half of that? Well, that's 7.5. Okay. This length of this, the bottom part of the triangle, right triangle, is always half of what that is. So now we want to use our Pythagorean theorem. A squared plus B squared equals C squared. So 23 squared plus 7.5 squared equals the slant length squared. So 23 squared, that's 529, plus 7.5 squared, that's 56.25, equals L squared. Add these two together. That's 585.25. equals L squared. How do we get rid of the squared? Well, we use the square root. So we square root both sides. That gives us that L is 24.19, roughly. So now we can find our lateral area, because our lateral area, to find that, is this formula. So it's 1/2 P, which we already discovered, P is 60. That's the perimeter of the base, times the slant length, L, which is 24.19. Let's go ahead and multiply those together. That gives us that our lateral area equals 725.76. Okay. Now, if you're writing down every step that I write everything I write, you write, you're going to have a much easier time. So make sure you're following along and putting in your calculator and doing all that, okay? Every step along the way. And make sure you understand how we got from one step to the next step, each step of the way. And if you could do that, then you're going to have a much easier time, okay? So don't just copy either. Make sure you understand how we got from one step to the next. With that in mind, I want you to try number 2 on your own, okay? It's the same exact thing we just did, just with different numbers. So go ahead and give that a try. Okay, let's go down to here. So now we want to find the surface area of these pyramids below. Okay, so here I'm going to do number 3, and I'm going to expect you to do number 4 on your own. So for these ones, you want to know what's the lateral area, and we're going to do plus the base area. So the lateral area plus the base area, that gives us our surface area. So this is basically what we're going to be doing. So how do we find the lateral area? Well, the formula for our lateral area is same as what we just did. So that's 1/2 P times L. What's P in our case? So P in our case is the perimeter of the base. So in our case, that's a hexagon, 6 sides. So, and each side is length 8. So the perimeter of this hexagon will be 8 times 6. Which is 48. So that's the perimeter of the base. So now we should be able to find the lateral area. So our lateral area will be 1/2 the perimeter of the base times the slant length, which in our case, the slant length, L, is 15. So here's our L. Let's go ahead and multiply that together. $360. So our lateral area is 360. Again, that's the area of all the triangles in this case. So that's the area of everything besides the base. All right, now that we know that, we could also find the base area. So what's the area? How do we find the area of the base? Well, we use this formula, 1/2 P, that's the perimeter of the base, times the lowercase a, that's the apothem. So in our case, that base is going to have an area of 1/2 times the perimeter of the base, that's 48 again, that doesn't change, times the apothem. So that's right here, 4 square root of 3. Okay. When you plug that in the calculator, you can just do 4 times the square root of 3, or 4 square root of 3. It should calculate it. But if it doesn't, just calculate it by just putting the 4 and then the square root of 3. You might have to put times, 4 times the square root of 3. Okay, so let's go ahead and do that. So 1/2, I just put 0.5 for 1/2, same thing, times 48 times 4 square root of 3. So make sure you plug that in your calculator and make sure you get the answer of 166.28. Okay, rounding to the nearest hundredth. So now we could find our surface area because the surface area is the lateral area, which we found right here, plus the base area, which we found right here. So that gives us our total surface area of 526.28. And that's it. See if you could do number 4 on your own. It's the same exact problem, just with different numbers. Okay, but if you followed along well here and you understood everything, then just try to do the same exact thing over here. Okay. Now we're going to talk about, let's go back up and to page 22, and we're going to talk about the surface area of a cone now. Now, same as before, you find the lateral area plus the base area. And again, the base, it only has one base. It only has one circle. In the case of a cone, it only has one base, the circle. And the lateral area is basically the cone part of it. Okay. Now, the way you find the lateral area for this guy is pi times the radius times the slant length. And that's the formula for the lateral area for a cone. So in our case, that's going to be pi times the radius, that's 8, times the slant length, that's 12. So our slant length here is 12, and 8 is our radius. So our lateral area, pi times 8 times 12, which is 96 pi. Then the area of the base is pi r squared. So it's the same as the area of a circle, right? Because the base is a circle. So you just need to find the area of that circle, which is pi r squared for that formula. So that's where they got this, pi r squared. In this case, our r is 8. So pi times 8 squared, that's 64 pi. Lastly, you add the lateral area plus base area to get the surface area. Okay. I'll go over an example here, and then I'll do number 5 with you guys, and then I expect you to do number 6 on your own on page 25. So let's go ahead and work this out. So we want to know what's the surface area. So we need to find the lateral area, and we're going to add the base area. So first, how do we find the lateral area? So our lateral area is pi times r times L. So in this case, that's going to be pi times r, that's our radius, that's 15, times the slant height, 23. So that's going to be 15 times 23, 345 pi. Now let's find the base area. So in our case, the base is a circle. So for every cone, the base is a circle, and we need to find the area of that circle. So to find the area of a circle, it's pi times r squared, which will be pi, times our radius is 15 in this case, which will be 225 pi. So for our surface area, you add the lateral area, which we found right here. That's 345 pi. plus the base area, which in our case is 225 pi. That gives you a total surface area of 570 pi. And that's it. I hope that that made sense for the most part. I want you to go ahead and try number 6 on your own. It's the same exact problem, just with different numbers. All right. Next, on page 26, we're going to talk about surface area. So the first thing we're going to talk about is the surface, or not surface area, you just did that. We're going to talk about volume. So volume is, for three-dimensional shapes, it's the amount of space that that shape occupies, right? So think about how much space this occupies, okay? Or the amount of stuff I can put inside is another way to think of it. So that's its volume, right? Now, how do we find the volume of prisms? Well, all you do is you find the area of the base and you multiply by the height. And that's it. So for volume, it's the area of the base times the height. Now, in this case, the base is a rectangle. So you just need to know how to find the area of that rectangle and then times the height. If the base is a circle, then you'd find the area of that circle times the height. If the base is a triangle, you'd find the area of that triangle times the height. So for volume, it's very, very similar for a lot of different shapes. Okay, so here's the example they give. Here they give a rectangular prism. They do the area of the base times the height. So how do we find the area of that rectangle? Well, length times width. So here's where you need to know your area formulas. So for a rectangle, it's length times width. So in our case, that's 12 times 20. Here, L is not slant length like we did before. Here's just length. So that's 12 times 20. That's 240. That's the area of the base. Length times width for that rectangle. Now, times the height to find the volume. So that gives you a volume of 5,760. Let's go ahead and do this one together. So first, let's find the area. So for volume, we need to find the area of the base, and then we multiply by the height. So in our case, the volume is going to be, well, we need to find our base. So the base area is length times width. So that's 6 times 11. So the area of the base in this case is 66. So for our volume, it's the area of the base, so that's 66, times the height, which is 13. So that will give this shape a volume of 858. All right. We're going to briefly go over Cavalieri's principle, but basically Cavalieri's principle says that if two prisms have the same height and cross-sectional area, then they have the same volume. So if you did the cross-section of two shapes and they had the same cross-section area all the way up the shape and they have the same height, then they would have the same volume necessarily. All right. So according to Cavalieri's principle, if two space figures, three-dimensional figures, have the same height and the same cross-sectional area at every level, then they have to have the same volume. Okay. Volume. Okay. This will be on the test, so make sure you know Cavalieri's. But basically, the cross-sectional areas are the same all the way through. So the area, if you cut it across and they have the same area all the way through, and they have the same height, then they'll have the same volume. Okay. Now let's go down. We'll talk about cylinders in a bit, but let's go down and work on these prisms down here. Okay. So I'm going to do one of them with you, and I want you to do the other one on your own. So how do we find the volume of these prisms? Well, that's the area of the base times the height. So in our case, that volume is going to be, well, the area of the base, let's do that to the side, will be length times width of that base. So that's going to be 19 times 14. So the base area, 19 times 14, is 266. So our base is 266. And then you multiply by the height. In our case, the height is 11. So that gives us a volume of 2,926. See if you can do number 2 on your own. So go ahead and pause the video and see if you can do number 2. Okay. Now let's talk about finding the volume of a cylinder. Well, it's pretty much the same as the volume of a prism. You find the area of the base, and then you multiply it by the height. The only difference is this base is a circle. So how do we find the area of that circle? Well, hopefully you remember the area of a circle is pi times r squared. We've seen that a couple times already. So for the area of the base, the area of that circle, it's pi times r squared. R is 4. That's our r. So pi times 4 squared, that's 16 pi. That's the area of that circle. Then to find the volume, you take that area, the area of the base, times the height. Same as what we've done before with the prism. The area of the base times the height. So that's the area of the base, that's 16 pi in this case, times the height. Height is 9. So that would be 144 pi. That's the volume, that's the amount of space that this shape occupies. Let's go ahead and do this example here on the quick check. So the area of the base, pi r squared, so that's the area of that circle. So that's going to be pi times r. What's our r in this case? Well, that's 5. So that's going to be times 5 squared. So 5 squared, that means 5 times 5, so that's 25. So our base area is 25 pi. The volume is the area of the base times the height. So the area of the base, that's 25 pi. We just found that. That's a 5. Oh, let me rewrite that. That was not good. So that's 25 pi times the height. So in our case, the height is 12. So that gives us a volume of 300 pi. Don't leave off pi. Always remember to bring that along. Let's go on to page 29. I'll go ahead and do number 3 with you guys, and you can do number 4 on your own. So let's find the volume. So again, the volume formula is the area of the base times the height. To find the area of the base, well, that's the area of a circle in this case. That's pi times r squared. What's our r in this case? Our r is 9. So that's going to be pi times 9 squared. In other words, 81 pi. That's the area of that circle. So our volume will be 81 pi that's the area of the base, times the height, 14. So the volume of this cylinder is 81 times 14. So that's 1,134 pi. Okay. So now that you've seen that example, see if you can do number 4 on your own. So go ahead and pause the video and give that a try. Once you're done with that, we'll move on to this. So the volume of a pyramid or a cone. So remember, for prisms and for cylinders, we did the area of the base times the height. Well, these ones still have that area of the base times the height attached. You see that? They still have the B times H, the area of the base times the height. The only difference is they have this 1/3 attached. So the way I kind of think of it is that if the shape comes to a point, comes to a vertex, like with a pyramid or with a cone, then that shape will have a 1/3 attached to its volume formula. So these ones are 1/3, but you still do the area of the base times the height. Okay, you just cut it by dividing by 3 or times 1/3, same thing. So let's just go ahead and work on this quick check on page 31. We'll work on these two quick checks. So the area of the base, in this case, this base is a square. So for a pyramid, this pyramid, the area of the base is or the shape of the base is a square. So to find the area, we do length times width. So that's 17 times 17, or in other words, 17 squared. So that's going to be 17 times 17, which gives us that the area of the base is 289. Now to find the volume, we're going to use this formula. It's 1/3 the area of the base, which is 289, times the height. Now the height of this is 23. So the way I would multiply these together is 289 times 23, and then divide by 3. So times 1/3 is the same as saying divide by 3. So that's 2,215.67. Let's say, rounding to the nearest hundredth. Same idea with a cone. You'd find the area of the base times the height, and then with 1/3. Now in this case, the base is a circle. So how do we find the area of that circle? Well, pi r squared. We've done this before. Whenever you see that circle, how do we find the area? Pi r squared. So that's going to be pi times r. What's our radius? That's 11. So that's our radius in this case. So that's pi times 11 squared. So that's going to give us 121 pi. So that's 11 times 11. That's 121 pi. Now let's find the volume. So that's going to be 1/3 times the area of the base, which is 121 pi, times the height. And the height of this cone is 15. 121 times 15 divided by 3 gives me 605 pi. Okay, let's go on. So let's go ahead and find the volume of this pyramid here. I'll do number 1 with you, and I expect you to do number 2 on your own. So for the volume formula is 1/3 times the area of the base times the height. So in our case, the base area, well, that's a square down here for the base. So the area of this is length times width, or in other words, 14 squared So the base area is 196. So our volume will be 1/3 times 196 times the height. And our height is 16 in this case. So 196 times 16 divided by 3 gives me that I have a volume of 1045.33. And there you go. That's volume. Give number 2 a try. Pause the video, give number 2 a try. Same thing, just different numbers. All right, for number 3 and number 4, it's the exact same thing, except they don't give you a picture, they just tell you in words. A pyramid has a square base with side 15, so you can go ahead and draw it if you want. So my drawing is not going to be that great, but you got a pyramid here. Great. So base with a side of 15. So both the sides of this 15. And its height is 23. So the height is 23. Okay, you can't really see what I wrote there, but maybe I'll just write to the side that the height is 23. Okay, what is the volume? So I'm going to help you set it up. The volume is going to be 1/3 the area times the area of the base times the height. The area of the base is 15 times 15. So the area of the base is 225. So our volume will be 1/3 times the area of the base, which is 225, times the height of the pyramid, which is 23. And let's go ahead and multiply that together. So 225 times 23, and then divided by 3. So 1725. Okay, now this is all in feet, so we'll put feet, and when in its volume, it's actually cubic feet. So if you imagine a 1 foot by 1 foot by 1 foot cube, this pyramid in this situation would hold 1,725 of those 1 foot by 1 foot by 1 foot cubes. Okay. Try number 4 on your own. So it's the same idea. You could draw the picture if you need to, but it's finding the volume. All right, now let's look at the cones. So we did a cone example earlier, but let's go ahead and do another. I'll do this one with you here. So the volume of the cone, again, is 1/3 the area of the base times the height. Now in our case, the base is a circle. So to find its area, it's pi times the radius squared. So in our case, it's going to be the area of the base will be pi times the radius in this case is 6. So that's 6 squared. So the area of the base is 36 pi. Now let's find its volume. Let's find the volume of this cone. How much space does it hold? So that's 1/3 times the area of the base, that's 36 pi, times the height, 14. So 36 times 14 divided by 3, 168 pi. So volume in this case is 168 pi. See if you can do number 6 on your own. Just go and pause the video, follow this one's example, and do number 6 on your own. Now, the last shape we're going to talk about are spheres. Now, a sphere is like a ball, right? Or a globe. Yes, the Earth is a sphere. It's not flat. And the way you can look at a sphere is it still has a radius, just like circles do. It has a center point. And there are things called great circles. So a great circle is a circular plane cross section that goes through the center. So imagine a cross section through the center where you get the circle, the biggest circle through the middle there. Okay. So indicate whether each cross section of the circles below represents a great circle. So the cross section needs to go through the middle. So this seems to look like that's a great circle there. So we're going to put yes. This one, no. You can see it doesn't go through the middle there. This one does. And this one does. Okay, so 3 great circles, 1 that's not a great circle. So first, let's talk about surface area of a sphere. Again, the surface area is the surface, right? So how much area is the surface of this object? So for a sphere, the formula for surface area is 4 times pi times r squared. So it says it's like the skin of it, right? So how do we find the surface area? 4 pi r squared. So in our case, that's going to be, for this sphere, that's 4 pi times r squared. So the r in our case is 12. So that's going to be times 12 squared. So that's 4 times pi. 12 squared, that means 12 times 12, that's 144. Let's go ahead and multiply that together. 4 times 144 gives me 576 pi. And that's how you find the surface area of a sphere. Now, to find the volume of a sphere, again, that's the amount of space it occupies, you're going to be using this formula here. Volume equals 4/3 times pi r to the power of 3. So r cubed is what we would say, r to the power of 3. So here's an example here. 4/3 times pi times r, which our r here is 6, the radius is 6, to the power of 3. So remember, when it says 6 to the power of 3, that means 6 times 6 times 6. So that's that number times itself. There's 3 in total. So that number times itself times itself. Then you multiply by 4, divide by 3. And that's how you would get that. So it would be 6 times 6 times 6 times 4 divided by 3. Keep the pi, and that's what it would be. Let's go ahead and do some connecting here. A great circle, well, we know what that is. The surface area, well, that's this formula. And the volume is this formula. So connect those there. And here, let's find the surface area of the sphere below. I'm just going to go ahead and get it started for you. I already showed you an example, and there's an example up here, but I'll get it started for you. So for our surface area, we want to be using the formula 4 pi r squared. So in our case, that's going to be 4 pi times 21 squared. So go ahead and finish that up. Figure out what 21 squared times 4. Keep the pi. Okay, that would be the surface area of that. Now for volume, I'll do number 5 with you, and I expect you to do number 6 on your own. So for volume of a sphere, we're going to be using the formula 4/3. You got to know these formulas, by the way, for this one. 4/3 pi r cubed. So that'll be 4/3 times pi times our radius, that's 4, to the power of 3. So 4 to the power of 3, that means 4 times 4 times 4. And then times 4 divided by 3. So that gives you that this sphere has a volume of 85.33 pi. Okay, that's the volume of this sphere. Make sure you plug that in your calculator. Make sure you get that same answer so you know how to do it. And then go ahead and try number 6 on your own. Okay, last problem. So you can, let's take a look at this one here. It says surface area of a sphere application. So example, find the approximate surface area of the planet Venus if the equator is about 7,521 miles long. Round your answer to the nearest square mile. So what they're giving you here, they're not giving you the radius. They're giving you the equator. Now, the equator is basically going around like a great circle. It's a great circle through the middle of the planet. That's the equator. Now, that's the same as the circumference of that sphere. So the circumference is 2 pi r. 2 times pi times r. That's what this number gives you. This is the circumference. So in our case, that circumference is 7,521 equals 2 times pi times r. So then what you can do is divide by 2 pi to find the radius. So divide by 2 pi and get the radius by itself. Divide by 2 pi. When you plug this in the calculator, I would suggest putting this in parentheses. So you do 7,521 divided by parentheses 2 pi, close parentheses. Okay, so make sure let's work on that together and make sure you get the same answer I get. So 7,521 divided by parentheses 2 pi, close the parentheses. I get that the radius of this planet, of Venus, would be 1,197 miles, right? So let's put miles, MI for miles. Okay, so that's the radius, and that's how they got that this radius is 1,197, okay? So they use that circumference formula because what they gave you was the circumference to help you find the radius. Once you have the radius, now you can find the surface area, right? Because the surface area formula requires the radius. So now we would do 4 for our surface area, 4 pi r squared. So that would be 1197 squared. So I'd square that times 4 times pi would give me a very large number, this number here. Okay. It says round to the nearest 1,000 square mile, so that's why they just put 000 at that. Okay. But make sure you plug this in your calculator. Make sure you get this rounded to the nearest 1,000. Okay. We'll work on this one together here. So what is the approximate surface area of the planet Mars if the equator is 4,222 miles long? So they give us the equator. So that's the same as them giving us the circumference. Now, if you recall, the circumference is 2 pi r. And they gave us the circumference is the same as the equator. So that's 4,222 equals 2 pi r. To get the radius, which is what we need, we're going to divide by 2 pi, both sides. Divide by 2 pi on the left as well. make sure we put this in parentheses when we plug it into the calculator. That way, if you don't put it in parentheses, it'll think you only want to divide by 2 and then multiply by pi. But that's not what we want to do. We want to divide by both the 2 and the pi, right? So 4,222 divided by parentheses 2 pi. Close the parentheses. So that gives us that our radius of Mars is 671.95 miles. Okay. Now that we have the radius, now we could find our surface area, because the surface area of a sphere, as we know, the surface area of a sphere has the formula 4 pi r squared. So that's going to be 4 times pi times the radius, which is 671.95 miles squared. Let's go ahead and multiply that out. So you do the squared first, right? So let's go ahead and square that. I got that's a pretty big number, 451,519, something like that, times 4 times pi. I've got that the surface area is 567,396,4.12. If you got something a little bit different, don't worry about it, as long as it's right for the most part. And this is miles squared for surface area. You do miles squared. I guess we should put mi for miles. Now it says round to the nearest 1,000 square mile. So 1,000 place, that's where this 3 is. So I want to round to this 3 here. So this 3 would round up because of that 9, right? So this would be 5, 6, 7. This 3 rounds up to a 4. Then everything else becomes a 0 behind it. Put a couple commas here. So 5,674,000 square miles. Okay, and this is your surface area. Okay, well, that was a long one, but I hope that all made sense. I hope you're able to follow along. If that all made sense, go ahead and try the review, all right? It's all the same stuff we've already covered. Just go through the review, do what you can. I'll make another video for covering the review where I just kind of go over it. But if you understood everything and you could always go back and look at different parts of the lesson, you should be able to do everything in the review as well. All right. Well, good luck. And I hope you enjoyed the lesson, and I'll see you guys next time. Take care.